In this video, we're going to talk about the Entity Framework and LocalDB. What the Entity Framework provides you is a consistent data access layer to connect to just about any SQL-based database system. The Entity Framework is specially designed to work with SQL Server, but it does work with other systems. LocalDB is a development environment database that allows you to attach and detach dynamically to files that are located on the file system or on the disk, versus firing up a full SQL Server, attaching databases, and managing it all through SQL Server Management Studio. So those are the two concepts that we're going to kind of touch on in this lecture. The first thing I do want to just kind of walk you through is Entity Framework. How do we get our hands on that? What do we do with it? Now, to add just about any major component to any Visual Studio application, but our MVC project in particular, what we're going to do is we're going to right click on References, and we're going to add a reference to the Entity Framework library. Now, add references, the first option, would allow us to bring in any local project or local DLL files, possibly ones that are saved on disk. Add service references allows us to call out to references that may exist out on the web, so calling web services or any of those types of things. Manage Nuget packages. Nuget is a DLL or library repository, and we're actually going to use Nuget to go out and fetch the Entity Framework from this cloud-based repository. So by choosing Nuget, we get a list of all currently installed packages. So that includes Antler, Bootstrap, jQuery, JSON.NET, Microsoft ASP.NET MVC is actually a Nuget package, as well as Razor and some other components. I want to switch on the left-hand side to Online and have Nuget.org selected. I'm actually going to revise that. I'm going to select All, and that will give us access to all packages both on Nuget and within Microsoft's own repository server. Now, what you can do is in the search you can type in Entity Framework and do a search. And Entity Framework will appear, and then we can choose Install. And what this is going to do for us is it's going to go out and fetch the Entity Framework libraries and install them into this project for us. Now, traditionally what you would have to do is go out to a website. You'd probably have to download a zip file with DLLs or an executable with an installer to install a set of DLLs. Nuget instead goes out and does all of that work for you. It downloads packages, it'll load them locally on your machine, and then associates them to your project. Plus, with Nuget, as packages become updated, such as MVC, Entity Framework, you can go in and actually update your Nuget packages, and then through that update your application to the newest release of a particular framework or library. So it's really nice, and it allows you to kind of have this auto update functionality for your projects. Go ahead and hit accept on the license agreement. It'll download and install the Entity Framework into my MVC project. I get a green checkbox showing that it's installed. I can also go under installed packages, and now we see Entity Framework included. I'm going to go ahead and hit close on that. So we now have the Entity Framework DLLs inside of our application. The next thing we need is LocalDB. LocalDB is an extension of Microsoft SQL Server 2012. It allows for you to create a database file on the file system on disk, and then attach it dynamically to the SQL Server engine without using SQL Server Management Studio. To do that, the first thing you need is an MDF file or a SQL data file. My recommendation throughout the rest of the term is that you store your MDF file inside of the app_data folder. Now, let me preface this. The LocalDB is designed specifically to be used for development purposes. It is not to be used in production. It can be used in production, but Microsoft does not recommend it. So if we right click on App Data, Add, and we'll choose New Item. the wizard will come up. The first option is a SQL Server database, so I'm going to call this my week 4 LocalDB. This naming is not relevant. I can call it simply week 4, but I choose to use LocalDB just as a reference for myself. I'm going to go ahead and hit add, and a new MDF file is created. So I now have a database file. This database file is completely empty. You'll see on the Server Explorer that there is a week4/local.localdb that exists now. We can open that and see inside of it that there are tables, views, stored procedures, functions, and all the other components of a SQL database. The Server Explorer acts as a mini version of SQL Server Management Studio. Hopefully you're familiar with that from your SQL courses. But it gives us the ability to view tables. We can right-click and do add table. We can right-click and add views, stored procedures, and etc. So this gives us the ability to manage that LocalDB file without having to fire up SQL Server Management Studio. Now, how do we take Entity Framework and link it to our LocalDB? Now, the first thing that we'll need to do is under Models, we'll need to add a new class, and not a controller class. We'll need to add a new class file, and what I'm going to create is a week 4 DB context. Now this class will act as our conduit between Entity Framework and the database. The first thing we want to do is, in creating this context, is we want to inherit from DB context. So :db context. This comes out of the system.data.entity namespace. And then the next thing that we'll want to do here is we're going to want to declare DB sets for all of the tables that we want to pull from within our database. And we'll get to that part in just a moment. So we now have a context defined as week 4 DB context. Inside of our web config, we can add a section to this web config under just below app settings called connection strings. And inside of here we can say add and then define the name of our connection string. We'll call it the same as our context name, so we'll call it week 4 DB context. And then the connection string value itself will be one to attach to LocalDB. Now personally, I don't remember what most of my LocalDB connection strings syntax is, so what I recommend doing is going out to connectionstrings.com. Connectionstrings.com is a great reference for just about any connection string you can think of. I'm going to scroll down here to SQL Server. I'm going to click on SQL Server, and then there's kind of a catalog of items that you can jump to at the very top. But what I'm going to do is I'm going to do a Control F, and I'm going to type LocalDB. And as I go down through here, I'll find all of the different LocalDB connection string options. The option that I'm going to choose is LocalDB automatic instance with specific file. And what I want to do is highlight this string. I'm going to do a copy. And then I'm going to jump back to Visual Studio. Still in my web config under my connection strings area. And inside of the connection string, I'm going to paste this connection string. Now, let's kind of just deconstruct this for a moment. We have server, LocalDB in parentheses / v11.0. This points to the LocalDB SQL Server engine on your machine. SQL Server should have been installed as part of your Visual Studio installation. If for some reason you chose not to install SQL Server, you can go out to the web and download SQL Server engine with LocalDB from Microsoft's website. If you need help with that, please let me know. Integrated security true, that'll just do automatic authentication. And then the kind of secret sauce to all of this is this attach DB file name. Currently it points to c/myfolder/mydata.mdf, which for us does not exist. What we want to replace it with is pipe data directory pipe slash week4-localdb.mdf. The pipe data directory pipe points to the app_data folder. It's kind of a exchange token. And then slash week4-localdb.mdf is the MDF file that we created under app data. So no matter where this project is on the physical disk, data directory gets resolved to the app_data folder. Pretty nice. So we now have a context, we have a connection string which hooks entity framework up to our database. So let's go ahead and create a database table and then add that DB set we were talking about. So I right click on tables, say add table. My design surface will load up, and once it's loaded I now have a new table template. We'll go ahead and leave the primary key ID field as it is. That'll come in handy for us later. And what I want to do is I want to mimic my student class. So I have a first name, last name, and a student ID field. All of these are strings. So in this table I'm going to create a first name and make it an nvar char 50 is a good number, non-nullable. Last name nvar char 50, non-nullable, and student ID nvar char 50, non-nullable again. So we now have these 4 fields. I'm going to come down into the T-SQL component. I'm going to replace the name table with student. I'll go ahead and hit save. And it's going to prompt me to actually save out the SQL, which is not what I want to do. I actually want to click update. And it's going to generate a script to create that table. I'm going to go ahead and hit update database. That script then gets executed. And if I come back over to my table in my Server Explorer and hit refresh, I now have a student table. To accommodate for the ID field, I'm going to add a property to my student class, public int ID. So I now have 4 properties to match the 4 fields from my database table. This is important that they match because what Entity Framework will do for us is that when we define our DB set, is that it will map from student to the student table, and it will automatically map each one of these properties by name to the appropriate field. As long as the field matches the name of the property, that mapping occurs for us automatically. So inside of our week 4 DB context, we're going to add a property that's public, and we're going to use the generic wrapper of DB set, and we're going to put the name of our entity class inside of our DB set. And this entity group or class will be of student. And then we'll just create a property name called students. And believe it or not, in the most simplistic sense, this is all we need to get Entity Framework up and running. We've now created this context. The context, again, acts as the conduit between our student class that's under our models folder and the student table, which exists inside of our week 4 LocalDB instance. By having the connection string inside of the web config match the name of our, no, it's not that web config, sorry, match the context, this connection string automatically gets mapped to our context. Now, let's kind of see all this work in action. So the first thing I'm going to do is I want to right click on my table again. I'm going to say show table data. What this is going to do is provide me a way to just key in some student data. So I'm going to type in Kevin Gantos 1 2 3 4 5. I'm essentially moving my data from my home controller into my database table. Apparently identity is not set to true on my table, so I'm going to hit escape here. I'm going to right click on my table again, and I'm going to open the table definition, which will bring me the designer. I'm going to click on ID. I'm going to go to my properties dialog, and then I want to go under identity specification, and then where it says is identity, I want to say true. So my ID field becomes the identity. So basically that means that ID will auto number. Hit update to generate an update script. It will update my table. I can go ahead and close out my table now. I can do a refresh. And now my ID field is not mutable. I can't make changes to it. So now I can say Kevin Gantos 12345, and it'll automatically set the ID to 1. So we now have one record. So inside of my controller, my home controller, under my Hello World action, I currently have a line of code that creates a student object and passes it to the view. If I F5 and load up this controller and action, this is my home index, so I'm going to go to home/hello world, and it comes back with hello world, first name Kevin, last name Gantos, student ID 12345. These are values that are coming straight from my controller's code. What I want to do though is I want to pull that data from the database. So I'll stop my debugger. This will become my variable. And what I want to do is I want to pull that data from the database, but I don't want to hit the DB context directly. Now you may be thinking, why? Why wouldn't you want to pull from the context directly? Well, pulling from the context tightly couples our application to that database. And what we really want to accomplish is we want to have a level of decoupling or de-integration. We want to make our application more flexible. So to do that, we're going to use the repository method, and this method basically says that between your data access layer and your actual controller, there should be a repository class that facilitates pulling and pushing data into your data store. So if we end up not using SQL Server in the Entity Framework at some point, and we decide that we want to instead use a series of web services, we don't change the repository interfaces or methods. Instead, we change the implementation of those methods to make them hit a web service. The controller and the code that the controller uses doesn't change because the repository definition itself does not change. The classes do not change. Our student class doesn't change. But the code inside of that repository can be completely rewritten and facilitate us to connect to a web service, or maybe we store things in a XML document, or maybe we just write them to disk. Whatever we would want to do, we can facilitate doing that by making adjustments to the repository itself. So I've gone ahead and created a student repository class, and I kind of just stubbed this out before the lecture. So what I'm going to do here is I'm going to say week for DB context, and I'm just going to create a private variable called context. I'm going to say this is a new week for DB context. Then inside of each one of these methods, I'm going to use that context to either get, add, update, or delete student data. So from context, I have a students property, and I can return a collection of students, and students itself represents every record in the student table. So by just calling context.students, I'm going to get all students. So if there was more than one student record in the student table, let's say there was 2 or 3 or 5, get all students would give me every student in that table. Get student by ID, I can say return context.students, and then I have a series of action methods. If you remember from our lecture last week on link, you'll notice some of these are very similar. We have things like select and where, and there's some additional methods that are of value, such as single or first or find. And these methods allow us to go through and actually seek through or basically generate SQL statements to pull data from that particular DB context or table, in this case students. Now we can write this as a link statement using our lambda expression. So we can say student dot find, and what this is looking for is key values, or our primary key records in that table. Now this is searching on student ID, so using find will not work because the student ID is a string field, which is not a primary key field. There is a primary key called ID, so we'll end up with a key conflict when we try to search on find. But we can say where, and then here's our lambda expression. So we're going to then write a lambda expression where we're going to be receiving a student. So basically we're doing a logical check for every student. So we'll say where the student's student ID equals the student ID parameter that was passed in. And then what we want is we want first or default. And first or default will basically say grab the first matching record that's returned from the where statement, or the default, which is null, if there are no matching records. So this student ID here is this parameter. This student ID is the property off of the student object that's being evaluated. So this is a nice shorthand way of doing our where statement. We could also do this as return. And we could say from s, or stu in context.students, where stu.studentID equals student ID, select stu, first or default. So that's another way we could do it using link. But personally, I find this syntax to be a little easier to read. Either one is valid. There's no performance gain from one versus the other. Basically, this latter syntax with link gets converted into this lambda expression set by the compiler. So you ultimately end up running this code even though you're writing your statements using link. Add, very similar. What we can basically say is context.students. There's an add method which takes a student entity, and we can take this template variable that's being passed as a parameter. This should be our student template for creating our student, and we'll pass that into add, and then we'll say var new student. And what add will do is it will add the template to the DB set, which basically means to you and I is it does an insert statement into the student table using the data from the template, and then it's going to return us a new student, which is basically that same record with an ID field. And then what we'll do is we'll return new student. So we'll get back that same student, but they'll now have a primary key. We can say context.students dot, and now that you would think naturally we would do update, but there is no update method. Instead, what we're going to do is we're going to say context.students.find, and what we can do here is we can do a find, so we can say where student.id, and then this will be the DB student, or the student from the database, and then we can copy properties between the objects. And that would look something like db student.studentID equals student.studentID. We'd have to do that for each one of these. Or there is a shorthand that works sometimes and doesn't work sometimes, so you have to kind of do some trial and error and some testing. For very simple DTOs, or data transfer objects, student being one of our DTOs, you can use this syntax. Other times you'll have to go through the logistics of actually copying property at a time data from your parameter into your database student instance. So to do an update for a simple DTO, you can say context.entry, and then you pass it an entity. In this case, it's student. And then you can say state equals modified. And then you can say context.save changes. And we actually need this save changes here as well. And what save changes does for us is it will actually go through and performs the commit to the database. Now, context entry student.state, what we're saying here is take our DB context, find the entry for this student. So it does a lookup on the ID, and then we're saying take this student object, this entry, and set its state as modified, telling Entity Framework that there's a change that needs to be saved. Then perform that save. Now the delete is very much like the add, so we'll simply say context.students.remove student context.save changes. So this is a simple repository implementation for our students. So again, we're not hitting the DB context directly, because now we have some flexibility where if we need to make changes to this implementation, we can make those modifications, and we still have the flexibility of swapping out this DB context for another context, for a different method of retrieval and submission of student data. But we know that we'll always have these 5 methods, and we'll always be either returning or consuming a student object. So back to our home controller, we'll now say stu equals, and then we'll need an instance of our student repository. So we'll say equals new student repository. So stu will be equal to new, or to student repo.get all students. And then from here, since this is an IEnumerable, we still have access to some of those lambda expressions. So we can go ahead and say first or default. So what this really means to you and I is student repository, go get all the students out of the student table, and then just give us the one off the top. Currently there's only one record, so that will just get us by nature that record. So we can then take that student and load it into our view. So F6, everything compiles, F5 to run. Go ahead and get rid of that extra tab. So we're now in our application. We can say home/hello world, and we're getting a compiler error. Additional information: the connection string weak for DB context in the application's config does not contain the required provider name attribute. So one piece that we missed in setting up our web config was the provider. So there's a third component here that we can provide, which is the provider name. And when you're connecting to SQL Server, it's system.data.sql client. So we'll set that. We'll F5 again, relaunch. Gonna kind of sneak in here and say home/hello world. And we have an error that was not handled by our user code. We'll go ahead and hit OK to that and continue. And it says object reference is not set to an instance of the object. So let's go ahead and do a little bit of debugging. So we'll put a breakpoint here on line 37. I'm going to refresh. So student repo exists, get all students, and then we have first or default. So stu is currently null. I'm going to do a step over on this line and see what stu is still null. Interesting. So if we mouse over get all students, and let's do a add watch, we'll see that we receive back a select statement. So what's happening is when we call get all students, we're actually receiving what's called a iQueryable, and that iQueryable contains the select statement. Now, something you'll notice in the select statement that's generated by the entity framework is that it's doing a select ID, first name, last name, student ID, from dbo.students. So it's looking for a table with a plural students. What we need to do to resolve that is we'll accept that error, we'll hit stop, is we're actually going to go back into our student class. And there are certain attributes, and if you've never dealt with attributes, they're very useful within the entity framework and MVC. We're going to do a square bracket above our class name, and then we're going to say table, and then parentheses. We're going to put in a string student. Now we get a compile time red line. There's a resolve that we need to do. That we need a using statement to go to system.componentModel.dataAnnotations.schema. That will then include the table attribute. We'll F6 to recompile, F5 to redeploy, and we'll actually get our data back from the database. Now, just to show that this is coming from the database, I'm going to go into my Server Explorer, my student table. I'm going to do show table data. This will bring me into my table data, and I can actually manipulate this. So we can say, instead of 1, 2, 3, 4, 5, we can say 9, 8, 7, 6, 5, 4. So I'm making that change to the database only. I'm going to go ahead and refresh. And by doing that refresh, we'll then refetch data from the database and present it in our view. So what's happening is our repo is going and fetching that data, giving us back the student object. That student object contains the data from the student table, and everything is presented. So by doing that and then adding our our table attribute with the student table name, so the student represents the name of this table. By adding that, we then have all the appropriate mappings and connections to enable our application to work using the entity framework and LocalDB. This will be the basic model for all of your applications moving forward. The use of LocalDB as your database, the use of entity framework as your conduit, and then creating repository classes to facilitate pushing and pulling data from your data store in your application.